Hello, Mr. Brown here, your science teacher. I make science videos for students of all ages. Do you like science? I know I do. In fact, I can't seem to stop talking about it. Why don't you join me today as we discuss the science of the Space Shuttle, America's Space Shuttle program, an amazing tribute to ingenuity and engineering. But why did we even need to build the space shuttle in the first place? We had perfectly good rockets. From the 1960s, the Apollo program used the Saturn V rocket, which worked great. The problem is, every time you used one of these things, the only part that came back was this little capsule right here with the astronauts. If you wanted to go back to space, you had to build a whole new one. That started to get expensive. So Congress said, why don't we design something that can be reused? Engineers got to work and had all sorts of really cool designs, and they're streamlined looking. And the military said, oh, by the way, we're going to need you to fit something about the size of a school bus inside here. And engineers went, wait, what? Back to the drawing board. And they worked on it for a long time and came up with the most complex machine ever constructed. The space shuttle was like nothing else anyone had ever seen. And they had a lot of very serious design problems. For one, how do we design engines that won't melt on liftoff? Well, the solution was to run freezing cold rocket fuel around the exhaust nozzles to keep them cool during launch. Well, how do we keep the shuttle from melting on reentry? Well, they came up with a breakthrough in heat shielding. All right, well, who are we going to get to fly this thing? Look at how complex. This thing launches like a rocket but lands like a plane. Never fear. Some brave men and women from across America volunteered to become astronauts for the Space Shuttle program. And some of those men went on to grow some of the most epic mustaches ever seen in space. The shuttle cannot get to orbit by itself. It needs two solid rocket boosters and an external fuel tank to make it there. Where are we going to put this together? Well, NASA said, we've got this vehicle assembly building we built back in the 60s. Why don't we make it in there? Okay, so inside the vehicle assembly building, which is one of the biggest buildings in the world, by the way, we put these components together. Now we have to get it out to the launch pad. And NASA said, well, we have these giant crawlers we built back in the 60s. Why don't we throw it up on there? Okay, now carefully, let's take this whole complex machine out to the launch pad. And it's going to be a 4-mile creep. Take it easy. You don't want to tip this thing over. It's really expensive. All right, so we make it out to the launch pad. Now let's put fuel into it. Let's double check everything. And the next morning, we are ready to go. Let's get those astronauts in there. Let's do a double check. Let's do a triple check. Let's make sure everything is ready to go. Remember, for every astronaut you see, there are a whole army of technicians and helpers making sure everything goes good. We are at T minus 11 hours to countdown. Why is there a minus sign? Well, that means it's before launch. It's a countdown. Once we launch, that'll become a positive sign and be a count up. All right, I'd like to watch it. And we are allowed to watch it, but from several miles away. There's the launch pad about 5 to 10 miles away, and we are ready to go. Minus 3, 2, 1, and blast off. The shuttle is headed towards outer space. Sometimes they launch at night. Look at this amazing night shot. Hey, did you ever notice what is this thing right here? That is a water tower. And what they do is they spray water during launch to cut down on the sound. The launch is so loud that it would shake apart the orbiter, not to mention scramble the brains of the astronauts. We need to get up to 17,500 miles per hour if we hope to reach orbit. But these solid rocket boosters are just the tool for the job. Inside the crew cabin, we have checklists, and we are going down the checklist, making sure we don't forget anything. Hey, why are these astronauts in orange? These aren't designed for space. These orange suits are designed to survive the ocean. In case of emergency, these astronauts are going to have to ditch out and jump into the ocean. And it's easier to find them if they're wearing orange. Several minutes into flight, and the solid rocket boosters have done their job. They're out of fuel, and we need to separate them off. And so here we see a shot of the solid rocket boosters detaching from the shuttle. They are going to drop down into the ocean, and we'll send out a team of guys to pick them up out of the ocean, rinse them off, and get them ready for the next one. A couple minutes later, and we're out of fuel in the external fuel tank. We're going to jettison that and let that thing fall back down to Earth, splash into the ocean. We'll send a team out there to pick that thing up, rinse it off, and get it ready for the next shuttle launch. All right, we are in space. We're in orbit, and we're going to circle the Earth once every 90 minutes. We can go ahead and unbuckle, take off our orange safety suits, and begin to play around in weightlessness. Zero gravity is a lot of fun. Here we see an astronaut upside down playing a flute, or wait, she says we are upside down to her. So which way's up, which way's down? It's hard to tell. So we have this little toy we played with as kids called a gyroscope. The shuttle has several different gyroscopes, all orientated so the shuttle knows which way is up and down for when it's time to make maneuvers like this roll where we flip over. A drink of water in space is fun. Here an astronaut is showing you how water behaves in zero gravity, but I'm hungry. Let's go to the astronaut kitchen. We have all sorts of different space foods available to us, and here we see an astronaut demonstrating how a meal in space might look. Well, food goes in, food's got to come out, and you'll have to head to the space toilet, a specially designed toilet to keep everything clean. And if you get tired, astronauts need to go to sleep too. Here we see some astronauts buckled in so they don't float around while they sleep. The 80s was a great time to be an astronaut. In 83, we saw Sally Ride become the first woman in space. Also in 83, we saw Guy Bluford become the first African American in space. And in 84, Bruce McCandless became the first untethered spacewalk. Bruce, get back over here into the spacecraft. Mission Control is telling us we've got work to do. All right, so open up those cargo bay doors and let's get to work. We've got satellites that need launching. We need to capture some stuff and give it repairs. Here you can see us docked and making repairs with these big robotic arms. Some of these satellites that we launch are top secret government spy satellites. Super sneaky. You know, somebody said, wouldn't it be cool if we brought up a space station piece by piece and assembled it in space? Okay, let's do it. They built the International Space Station doing exactly that, piece by piece over many years, and it's still up there today. The shuttle was responsible for bringing up fresh supplies and taking crew members back and forth, and it's time to go back to Earth. We are going to go to re-entry back into Earth's atmosphere. There's no fooling around. This is serious stuff. We're going to have to make a couple of maneuvers and get the heat shield in just the right angle so we don't burn up, because we are faced with 3,400 degrees Fahrenheit during re-entry. It is so hot and dangerous during this that we are in communications blackout for several minutes. We have no communication with mission control, but that's okay because we have some of the best technology in the world right here in the cockpit. Where should we land? Well, we could land at Edwards Air Force Base in California, but I'd like to land at Kennedy Space Center. Why? Well, Kennedy Space Center has a 15,000 foot long runway. I like that because we're coming in with no engines. The shuttle is just gliding at this point. We have no room for error. We got to get it right the first time. We have made it to the runway and we're going to deploy a drag chute to slow us down. We come to a stop and everyone's there to meet us. They've even sent a little bus to carry the astronauts back home. Now, if we did land in California, how are we going to get the shuttle all the way back to Florida for the next launch? Well, that's okay. We have a modified 747 that carries the shuttle across country back to Florida. The Space Shuttle program built 5 shuttles. We had the Columbia, the Challenger, the Discovery, the Atlantis, and the Endeavour. And they all performed great. However, we did have some tragedy. I'm sorry to report that in '86, we lost the Challenger and all 7 crew. And in '03, we lost the Columbia with all 7 crew. These 2 tragedies, along with mounting expenses, finally forced the program to shut down. In 2011, the shuttle program ended and we sent them to museums. This is a strange sight as one of the shuttles made its way to a museum. Today, you can find Shuttle Atlantis at the Kennedy Space Center in Florida, open to the public. Go and check it out. Or Shuttle Endeavour is at the California Science Center, or in DC, you will find Shuttle Discovery. The Space Shuttle program, 30 years, 135 missions, a job well done. I want to thank my good friend Kara for inspiring me to make this video. All right, that's all for now. Thank you and see you next time. Bye.